graders, it's Mrs. Thompson. We're going to talk about section 7.5. Today we're going to, first in this particular example, we are going to talk extensively about factoring perfect square trinomials. Now let me give you a fair reminder here about perfect square trinomials. If you square a binomial, do you remember from chapter 6, what do you always get when you square a binomial? Okay, if you are thinking perfect square trinomial, you are absolutely right. We have a three-step shortcut that we learned in chapter 6. Here's our first step, square the x. Done. Here's our second step, multiply x times 1, then double that. So 1 times x is 1x, 1x doubled is 2x. Then square the second number in the quantity. 1 squared is 1. There's your perfect square trinomial. Okay? So that's what we learned in chapter 6, was how to square a binomial to get this perfect square trinomial. I'll just shorthand it PST. Okay? Now they're going to give us the PST, the perfect square trinomial, and they're asking us, what were the original binomials? What did you originally multiply together to get this trinomial? And we're working our way backwards. You can do it the good old traditional way that we learned in section 7.3 and 7.4, where you can find factors of the last number that add up to be the middle number. That's fine. You can do that in letters A, not B, C, D, and E. B and F, you would have to actually factor those out using our 7.4 strategy that we learned, where we multiply in B, 4 times 9 is 36, factors of 36 that add up to be negative 12. You know all that, what that we learned in 7.4, okay? And factoring it that way by grouping. I want to show you a shortcut. You know, if it's actually a perfect square trinomial, there are ways to tell, and I kind of glossed over it earlier in the chapter, how to tell you have a perfect square trinomial. First thing, look at the first term. Our first term has just a single variable. Does the variable have an even exponent? Okay, if it does, then that's perfect square. So the first term has to be a perfect square. The last number has to be a perfect square. The last number also must be positive. If it's not positive, it is not a perfect square trinomial. It's just a regular trinomial that looks like a perfect square trinomial. It is just not perfect, okay? So what we want to do, if we think we have a perfect square trinomial, then what we want to do is, this is your shortcut. Then if it is, then it should be originally some binomial that you squared to get that trinomial. So here's how you do it. Once we think we have a perfect square trinomial, you're going to start here with your first term, x squared. What did you square to get x squared? You're right, x. Go to the last number, 36. What did you square to get 36? Right, 6. And then I always look at the sign of my middle term. My middle term is positive, so the positive sign is what I'm going to use here. Okay? I use the middle term to guide me as far as sign. That's the middle term doesn't have to be perfect. The middle term just tells me what sign to use. Okay? Now, I'm going to encourage you to do this. You need to check your work. It does not take long. Just check, do your three-step check, and make sure that this trinomial is what you started off with originally. Okay, let's start here. X, we need to square it. That's x squared. Now we're going to multiply x times 6, then double it, so that's 12x. And then we're going to square the 6. That's 36. It checks out. It's exactly what I started with. This is how I factor a perfect square trinomial. Okay? Let's try this one. B is also, appears to be a perfect square trinomial. Okay? I look at that because the 4x, 4 is perfect, as is the x squared. 9 is perfect, and 9 is positive. That's pretty good evidence it could be a perfect square trinomial. So I'm going to put a set of parentheses. I know it's something squared, a binomial squared. So let's start right here with 4x squared. What did I square to get both the 4 and the x squared? You're right, if you said 2x. What did I square to get 9? 3. And then I look at the sign in front of my 12x. It's negative, so this should be negative. Okay, so let's check it. Let's do our 3-step check. I need to square the 2x. I need to square the 2 and the x. Right, that's 4x squared. Second step, multiply 2x times negative 3. Then double that. That's negative 12x. Then square negative 3. That's positive 9. And I got what I had originally. So I know for a fact this is how you square, or this is what was squared to get that perfect square trinomial. Okay? All right, let's look at C. I suspect it's a perfect square trinomial because of the x squared being perfect, 16 is perfect, and 16 is positive. So good evidence. So let's give it a shot, see if we can come up, what we can come up with. All right, let's take a look. We've got, what did I square to get x squared? Yep, x. What did I square to get 16? 4. 9 is positive in the middle, so I'm going to put a plus sign here. Now, it's essential that you check this because it may not check out. And if it doesn't check out, that just means this is not a perfect square trinomial. It's a trinomial, but it's not a perfect square trinomial. And that's why you should check it. All right, so let's start here. Square the x, so we got x squared. Multiply x times 4, that's 4x. Double 4x, that's 8x. And then square the 4, that's 16. Uh-oh, Houston, I see a problem. Do you see what I see? I got a middle term of 8x, but my original problem has a middle term of 9x. Guess what, guys? This is not a perfect square trinomial. It's not, okay? So one way you can tell is when you multiply the first term times the second term and then double it, if it's not the number in the middle of your trinomial, then that's not how you factor it. So this is not a perfect square trinomial, okay? All because of that middle term. Thank goodness we checked. Thank goodness we checked, guys, because if we hadn't checked, we would have written down our answer as x plus 4 squared, and that's not the answer at all. It's not a perfect square trinomial. So it is essential that you check this, okay? It doesn't always look, it may look like it, but it may not be, all because of that middle term. First term may look great, last term may look great, last term may be positive, but if it doesn't check out when you do your 3-step check, then it's not a perfect square trinomial, okay? So is it even factorable to begin with? Well, you're not going to be able to use your shortcut here. You're going to have to make a list of your factors of 16, and here are your factors of 16. Do any of them add up to be 9? And you know what? None of them do. So it's not only not a perfect square trinomial, it's also not factorable. It is possible. I mean, I'm sure some of you considered that. Not every trinomial is factorable. So don't assume that I see a trinomial, it has to be something I can factor. It just may not be something you could factor at all. And we call that in algebra not factorable. And so you just leave it alone. Okay, so it's not a perfect square trinomial, and then we just checked it to see if we could factor it, and we realized I can't factor it. I don't have any factors of 16 that add up to be 9. Okay, so not factorable. So they did throw in a pretty tricky one for you. Okay, so here's another one. Let's get back on track. We think it's a perfect square trinomial because first term's a perfect square, last term's a perfect square, last term is positive. So let's just build it. Let's see what happens, and then we'll check it. So what did I square to get x squared? X. What did I square to get 4? 2. Middle term is positive, so I'm going to put a plus sign there. And then I think that's how it should be. I'm not going to walk away from it. I'm going to make sure I'm You have the right answer. So let's do our three-step check. Square x, that's x squared. Multiply x times 2, that's 2x. Double it, that's 4x. And then square the 2, that's 4. So it does check out. I just double checked it, and that actually is my answer. Okay? I'm going to leave the last two for you. I will tell you there is some trickery in here. I'm not going to tell you which one is tricky, but you need to check both of them. Okay? I think if you check it, you will catch it and catch to see which one is not factorable. I will give you that hint. One of the ones at the bottom of your page there is not factorable. Okay? So good luck with that. Bring your questions to class and we can talk about it a little bit more tomorrow.